Friends, individual gases tell individual stories, but TCG, total combustible gases, tells the whole story at once. TCG is not a gas. TCG is a summary of all combustible activity inside a transformer. When TCG rises, it means energy is being released somewhere, thermal, electrical, or chemical. That's why utilities, insurers, and asset managers always ask one question first. What is the TCG value? In today's Electroverse episode, we decode total combustible gas, TCG. What gases are included in TCG? Why TCG is used as the first screening tool. Difference between slow aging versus active fault. Using TCG, IEE condition-based interpretation of TCG. Why TCG trend is more important than absolute value. And how senior engineers decide urgency using TCG. Stay till the end. Because TCG doesn't tell you what failed. It tells you how serious the situation is.
This is the episode where engineers stop analyzing individual gases and start making decisions. When you've been working with transformer dissolved gas analysis for years, you reach a point where the complexity of individual gas interpretation gives way to something more powerful. A single number that tells you exactly how urgent your situation is. That number is total combustible gases, or TCG. Let me explain what TCG really means. Total combustible gases is the sum of all combustible fault gases dissolved in transformer oil. According to IEEE 57.104, TCG typically includes hydrogen, methane, ethane, ethylene, acetylene, and carbon monoxide. Notice that carbon dioxide is not included because it's not combustible. This is a critical distinction that many engineers miss in the field. Think of TCG as your transformer's overall health score. It doesn't tell you which fault is happening, but it tells you how serious the situation is. When you're standing in front of a transformer at 2 in the morning with the DGA report in your hand, TCG is what helps you decide whether you can wait until morning or need to call the emergency crew right now. The beauty of TCG lies in its simplicity for risk ranking. While individual gas analysis requires you to consider multiple ratios, trends, and fault mechanisms, TCG gives you a single numerical view of overall fault activity inside your transformer. This makes it invaluable for maintenance prioritization, management decisions, load adjustments, and outage planning. When you have 50 transformers to monitor, TCG helps you focus on the ones that need immediate attention. IEEE 57.104 defines 4 distinct TCG condition levels, and understanding these is crucial for any engineer working with transformers. Condition 1 represents normal operation with TCG below 720 parts per million. At this level, your transformer is operating satisfactorily and you can continue with routine monitoring. This is your green light. Everything is functioning as expected. Condition 2 covers the elevated range with TCG between 720 and 1920 parts per million. This indicates greater than normal combustible gas levels. You're not in immediate danger, but increased vigilance is required. Think of this as your yellow light. Proceed with caution and increase your monitoring frequency. Condition 3 represents the high range with TCG between 1920 and 4630 parts per million. At this level, a fault or faults are probably present. You need to take DGA samples frequently enough to calculate the amount of gas generation per day for each gas. This is your orange light. Action is required and you need to start planning for potential interventions. Condition 4 is the severe range, with TCG above 4630 parts per million. This indicates excessive decomposition of cellulose insulation or oil. The standard clearly states that continued operation could result in failure of the transformer. This is your red light. Immediate action is required and you should be preparing for an emergency outage. This classification system acts like a traffic light system for transformer health. It guides your operational responses and helps you communicate risk levels to management in terms they can understand. When you tell your supervisor that a transformer is in condition 4, they immediately know the urgency without needing to understand the complexities of gas ratios and fault mechanisms.
But here's the key point that separates experienced engineers from beginners. TCG must always be interpreted with individual gas composition. This is the heart of TCG interpretation. High TCG dominated by carbon monoxide means aging of cellulose insulation. High TCG dominated by acetylene means immediate danger from arcing faults. The same TCG value can represent completely different scenarios depending on which gases are driving the increase. Let me give you a practical example. Imagine two transformers, both showing TCG values of 3000 parts per million, putting them in condition 3. In the first transformer, the high TCG is primarily due to carbon monoxide, indicating thermal aging of paper insulation. This is serious, but manageable with proper load management and monitoring. In the second transformer, the high TCG is driven by acetylene, indicating arcing faults. This transformer needs immediate attention and possible emergency shutdown. This is why senior engineers use a two-step approach: TCG for classification and individual gases for diagnosis. TCG tells you when to act, while other gases tell you how to act. Never panic over TCG alone, but never ignore it either. The trend of TCG values is often more important than a single absolute value. A rapidly increasing TCG, even if still in condition 2, might be more concerning than a stable high TCG that's been constant for months. Understanding the limitations of TCG is equally important. TCG does not identify fault type. That's the job of individual gas analysis and ratio methods. TCG is fundamentally a risk management tool, not a diagnostic tool. It helps you prioritize your resources and make informed decisions about transformer operation, but it doesn't replace the need for comprehensive gas analysis when determining the specific nature of a fault. In the field, I have seen engineers make the mistake of focusing solely on TCG values without considering the broader context. Remember that factors like transformer design, oil volume, operating temperature, and even the presence of oil additives can influence TCG levels. A sealed transformer will naturally have higher gas concentrations than a breather-equipped unit because gases escape more slowly. The practical application of TCG extends beyond just monitoring. It's a powerful tool for asset management decisions. When planning maintenance schedules, TCG helps you identify which transformers need priority attention. When justifying budget allocations for transformer replacements, TCG provides objective data to support your recommendations. When training junior engineers, TCG offers a straightforward entry point into the complex world of dissolved gas analysis. As we conclude this deep dive into total combustible gases, remember that TCG represents the evolution of transformer diagnostics from complex analysis to practical decision-making. Individual gases diagnose faults, ratios explain mechanisms, but TCG decides urgency. It's the bridge between technical analysis and operational reality, helping engineers make confident decisions that keep our power systems reliable and safe. The next time you are reviewing a DGA report, start with TCG to understand the urgency. Then dive into individual gases to understand the problem. This approach will make you a more effective engineer and help you protect the critical infrastructure that powers our modern world.
So friends, this is the real meaning of TCG in DGA. TCG does not diagnose a fault. TCG measures the intensity of fault activity. It combines hydrogen, methane, ethane, ethylene, acetylene, and sometimes carbon monoxide. Remember this rule forever. Individual gases. Fault type TCG. Fault severity. Low TCG with stable trend means normal operation. Rising TCG means fault energy is increasing. High TCG means immediate attention is required. When TCG rises rapidly, you don't debate limits. You correlate with individual gases, you check loading and cooling, and you plan corrective action. If this explanation helped you read DGA like a senior condition monitoring engineer, then support Electroverse. Like this video. It helps serious engineering content reach professionals. Comment below. What was the highest TCG you've seen in service? Subscribe, because Electroverse teaches interpretation, not guesswork. Next, we'll bring everything together with a complete DGA decision tree and real case studies. You've been watching Electroverse, where every spark tells a story. Stay charged, stay safe, and happy.